Hello, in this video, I'm going to talk about how to graph polynomial. So first of all, short-run behavior. So when it comes to short-run behavior, we know that this is about intercept. Okay, so for y-intercept, that's easy because we only for all of the graph, because by the vertical line test, we know that you will only have one y-intercept. But for x-intercept, they could have a multiple one. So how do you determine the x-intercept? If you take a look at these x-intercept, they have different behavior. These three, we call it cross the x-axis or the horizontal axis, right? And then for this one, we call it bounce the horizontal axis. So what determines the bounce or cross? Well, that is determined by the multiplicity of a polynomial. So what is multiplicity? So look at this polynomial. X plus 2 squared s minus 3 to the cube, s plus 4, and then s minus 6 to the 4th power. So the multiplicity is determined by the factor's power. So in this case, in this example, this is the multiplicity. This is the multiplicity of this term, and here is the multiplicity. You don't have 1, that means this is going to be 1, and then this is 4. So that is the multiplicity of horizontal intercept, because we know that the horizontal intercept is going to occur at each factor, right? These are the horizontal intercept. When the function equals to 0, we have x equals to -2, x equals to 3, x equals to -4, and x equals to 6. And then the multiplicity at x equals to -2 is equal to 2, right? So that means you have multiplicity of 2 at s equals to 2. And then this one multiplicity is equal to 3. And for this multiplicity is equals to 1. And the multiplicity of the last x-intercept is equal to 4. It's just determined by the power. Okay, and then the next step is we need to determine if this is odd or even. If it's an even number, the behavior at this x-intercept is going to be a bounce. And if this is an odd number, the behavior as this x-intercept is going to be a cross. So if it's an odd number, it's going to be a cross. So this is an odd, so it's going to be a cross. This is an even, it's going to be bounce. You can think about this way. Y equals to x squared. It's going to look like a parabola, right? A parabola. Parabola looks like what? Bounce. If y equals to s to the cube, an odd number, the graph is cross. The short-run behavior. That means what happened in between, in this part, not the end behavior. So you can think about that. If you think about that, if the multiplicity is an even number, it's going to be a bounce. If it's an odd number, it's going to be a cross. Okay, with all of these, that's all we need to know to how to graph a function. Now, take a look at this example, and I want you to graph this function. G of t equals to t minus 2 squared times 2t minus 3. So we need two things when coming to the graph. We need the long run behavior and the short run behavior. Okay, so long run behavior is determined by the leading coefficient, right? So when you look at this function, what will be the leading coefficient? The leading coefficient is going to be t, the highest term for the first factor is going to be t squared, times 2t. So that means the leading coefficient, you're going to have a 2 times t to the cube. So the function is going to similar to this one in the long run. So that means long run means these two ends. So that means the polynomial as t goes to infinity, g of t also goes to infinity. As t goes to negative infinity, g of t goes to negative infinity. Okay, now let's take a look at the short run behavior of the polynomial. The short run behavior determined by the y-intercept or vertical intercept and the x-intercept. So for y-intercept, relatively easy. You substitute t equal to 0 into the function. I have g of 0 equals to negative 2 squared times negative 3. So I have a negative 12. So that means the y-intercept is 0, negative 12. Now x-intercept. So for x-intercept, I want the function g of t equals to 0. That means I have t minus 2 squared and 2t minus 3 equals to 0. And then when I solve it, I know that each factor, t minus 2, equals to 0, or 2t minus 3 equals to 0. When I solve it, I have a t equals to 2, or t equals to 3/2. So we will have two x-intercept. One is 2, 0. The other one is 3/2, 0. But that's not done. We still need to discuss about the multiplicity because we need to find out the short run behavior at the x-intercept. Okay, so for the first x-intercept, it's come from this factor, right? So that means the multiplicity of 2, 0, that first intercept is 2. And then the multiplicity of the second x-intercept is going to be 1, right? Because your power of this factor is equal to 1. Okay, if it's 2 even number, the short run behavior is going to look like the short run behavior of a quadratic function. That means this is going to be a bounce. And for an odd number, the short run behavior is going to look like a cubic function, which means it's going to be a cross. Okay, with all of this information, we can draw the graph. All right, so I know that the graph for long run behavior is as t goes to infinity, g of t also goes to, let me use a green one, as t goes to infinity, g of t goes to infinity. So that means they ends in here, and then as t goes to negative infinity, g of t also goes to negative infinity. That means on the left ends to the lower part, the third quadrant. And okay, and it has a y-intercept at 0, negative 12, has two x-intercept. One is at 3/2, 0. The other one at 2, 0. All right, and we know that at 3/2, 0 is going to be a cross, and then at 2, 0 is going to be a bounce. All right, so now let's connect all of these dots together. Well, the function starts at the third quadrant, right? Let me draw it a little bit lower. At third quadrant, and nothing going on, you always go up, you hit the y-intercept, and then when it comes to the first x-intercept, you go up. Okay, come back, because you want to hit the second x-intercept. Oops. And then at the second x-intercept, you're going to bounce and connect it to the end of the function. So that's the graph of the function. Of course, you can draw something nicer than I do, which is draw something much more smoothly, which is cross, something like that. So that will be the graph of this function. So with this graph, there's so much thing we can do, such as we can solve a polynomial inequality. For example, I want you to solve f, let's say x plus 3 x plus 1 squared and times x minus 4 greater than 0. So how do you solve this inequality? Well, I need to know what does the graph look like and find out which part of the graph is greater than 0. Then we will have the solution. All right, so that means we need to graph this. It's a polynomial. Okay, to graph this, we need a long-run behavior of the function. That means we need the leading coefficient. The leading coefficient is going to be what? S to the fourth, because, the leading term is going to be x to the fourth, because you have a 1x, 2x in here, and 1x. So that means the long-run behavior is going to be similar to x squared. It's parabola. A parabola look like what? As x goes to infinity, y also going up. If x goes to negative infinity, y also goes to positive infinity. Because a parabola look like this one. There's no negative sign, so that means we don't need to flip the function. Okay, for short-run behavior, we will have y-intercept and the x-intercept. So for y-intercept, when x equals to 0, I have 0 plus 3 times 0 plus 1 squared, 0 minus 4. So that gives me negative 12. Ooh, it's the same one that we did, is it? Let me take a look. Oh, no, that's a different one. Okay, but they have the same y-intercept. All right, so that means our y-intercept is negative 0, negative 12, and then x-intercept. For x-intercept is you want the function equals to 0. No, x should be x. So that means I have 3 x-intercept. One is negative 3, 0, negative 1, 0, and then 4, 0. After that, we need to find the multiplicity. So multiplicity of the first intercept is what? 1, because the power is 1. For the second one is 2. So the multiplicity of the last one, it didn't say in here, that means it's 1. Because the power 1 is itself. With the multiplicity, we know the short-run behavior. If it's an odd number, it's going to be similar to a cubic function short-run behavior, which means it's a cross. This is like an even function, which is a bounce. In here, it's going to be another cross. Okay, so after we're done with that, we can draw our graph. So the end behavior is going to be up. When x goes to infinity, y goes to infinity. When x goes to negative infinity, y also goes to positive infinity. And then you have a y-intercept at negative 12, and then you have 3 x-intercept at negative 3, -1, and 4. And for each x-intercept, you will have a cross at first 2, and then a bounce at the last one. Now, with all of this information, we can connect all of these together. I will get cross the first intercept and go up. Okay, well, if I go up, that means, hey, I can connect back to my y-intercept. My y-intercept has to be up. That means you did something, I did something wrong. I did something not correct, so that means I need to go back and check what's going on. Well, my y-intercept, no problem. And now we check the x-intercept. All the x-intercept is correct. And for the multiplicity, it has 1 degree. So that means this is cross. 2 degree is bounce. Oh, I didn't bounce this. I write this wrong. Okay, so if I change this back, this is a bounce, and this is a cross. So let's see if that works. Well, we cross the first one, go back up, bounce back, connect the y-intercept, and then cross the last x-intercept and connecting to the end. Well, this works. So this is one way to check if your answer is correct. All the dots has to be connecting together. If it's not, you need to go back step by step to do troubleshooting. This is a very important skill. Okay, so now let's go back to the question. What did they ask you? They asked you, hey, when does the function greater than 0? Well, greater than 0 means on the graph, it should be the part that above x-axis. This part is the function above x-axis. That means the function greater than 0. So that means in which interval? So in interval from -infinity to -3, and the interval from 4 to positive infinity, the function y greater than 0. So here is the solution. So here is the application for the graphing